My dear students, in my last lecture, we discussed about the optical instruments, which is divided into the two types. One is called here the microscope, second one is your the telescope. The microscope is divided into the two types, one is the simple microscope, another one is the compound microscope. On that class, I said to you that the second type of the optical instrument name is your the telescope. It is the combination of the two words, one is the tele, second one is the scope. As I said for the microscope, it is also combination of the two words, one is the micro, second one is the scope. Micro means small, scope means to provide some chance. Similarly, I said that my students, you please remember or you just re-guess what is the meaning of your the tele. I given some words relating to your the tele, one is the telephone, teleprinter, television. Likewise, the optical instrument name is your the telescope. So, during this time you probably must have remember or you must have recalled what is the meaning of your the tele. The tele, the meaning means that is your the distant. So, telescope, it is a combination of the two words, one is the tele, second one is the scope. Tele means your the distance, scope means your the chance, and the chapter in which we are discussing, that is the optics, which is related with your the light. So, due to the light, if we have some arrangement due to which an object which is present very away or the far away from us, but that vision is to be localized in front of us, then that type of the optical instrument is known as your the telescope. But in case of the microscope, an object which is placed before us, it is very small and its larger size to be placed before us. But in case of here the telescope, the size of the object there is no change, but the position of the object is shifted from your the farther distance to your the smaller distance. But the smaller distance means at what distance that should be placed, for which you can have it the good visualization, and we know that there is a point for our the normal eye, where if a thing will be placed at that position, it will give it the clarity of the vision, and that distance from the eye is known as the distance of distinct vision. Therefore, in case of the telescope, the object means like our the uncle or like our the mousy. Similarly, the things, uncle means the mama, mama means your the moon. So, if the moon is remain far away or the stars are remains far away, but they cannot be visualized to us, and by using some optical instrument, which we said that that is your the artificial one, that is not the natural, but the natural one is our the eye. By using that artificial one, if the position of the moon or the sun or the stars which are far away, lakhs of the kilometer from us, but we can see them, then that type of the arrangement is your the telescope. That telescope is divided into the two types that we will now going to discuss. And on this class, we also start about your the another topic of your the optics, that is your the wave optics. So, what to be discussed in this chapter? That is your the telescope, the wave optics, and the wave optics the fundamental concepts which was given by your the Huygens, and Huygens has provided some principles, that is your the Huygens principles. By using the Huygens principle, we will prove the laws of reflection, refraction, and your the Young's double slit experiment. These things we will discuss today. So, let us now go to find what will your the mathematical expression and its the diagrammatical form for your the telescope. So, what is the meaning of your the tele? Tele means your the distant, and the second one is your the scope. So, that is your the telescope. This telescope is divided into your the two types. One is called your the refracting telescope, one is your the reflecting telescope. So, according to your the revised syllabus, we only have your the reflecting telescope, but not your the refracting telescope. This refracting telescope is divided into your the two types. One is your the astronomical, and second one is your the terrestrian. Second one is the terrestrian, one is the astronomical. Astronomical means regarding to the word of the astrology or the astrologist, as you know that, means the objects which are remain in the heavenly forms, means far away from us but at a greater height. So, but the instrument which is used to have its the vision, that is your the astronomical one. And the next one is the terrestrial. Terrestrial meaning your the surface. So, on the surface of the earth, if an object, suppose a tree is far away from us or a home is far away from us, suppose you are observing a game, suppose for your the cricket, a ball being your the thrown. But what is its the position, where it being your the dropped? You are on your the pavilion or on your the gallery, but that object which is the very very small, that cannot be visualized by to you. Therefore, you are using the binoculars. So, that type of the instrument which is used for its the vision on your the surface, that is your the terrestrial one. Next one will go for your the reflecting. This reflecting is also your the two types. But what is the basic difference between this refracting and your the reflecting? This refracting means where the refraction is taking place. So, where the refraction is taking place, my students, you know that in case of the lens, the refraction is taking place, means when the ray is going from one medium to the another medium, that is the refraction. But this is the reflecting type, means the process of the reflection. So, what is the process of the reflection? When some rays will fall on your the surface and it will return to your the same medium, then that is your the reflection. So, by using your the reflection concept, if your the artificial telescope being your the used, that is called your the reflecting one. This reflecting is of your the two types. One is your the Newtonian and second one is your the Cassegrain. So, there are the two types of your the reflecting telescope. So, let us now go for your the first one, that is your the Cassegrain. Or Cassegrain type of your the telescope. So, the process is your the reflecting one, means we will take a mirror. For the reflection, as I said now, for the reflection you have to use your the mirror. But what type of the mirror you have to use? This is your the paraboloidal spherical. Paraboloidal spherical mirror you have to use, but never draw the diagram because some modification will be happen here. This is a ray, this is the ray. So, in case of here the telescope, the object is placed far away, means the object is here the infinite distance. From the infinite distance, the ray to be here the come. So, when the ray will come from here the infinite distance, and this is its the optical axis, ray is coming parallel. After reflection, what will happen? It will come to your the meet at a point, that is your the focus. Suppose this ray and this to be your the reflect, and this is the another ray, this ray to be your the reflect. So, they to be meet at a point, and that is its the focus. So, here the image to be your the formed, but actually the image is not forming here. We have to use another type of your the mirror, and that is your the convex mirror we have to take. You see, we have first taken your the paraboloidal of your the concave one, this is your the convex one, both are your the mirrors. Therefore, the process to be your the reflection. Therefore, the name is your the reflecting telescope of your the Cassegrain type, means the name of a person. So, while this ray is coming for your the first one as the reflection to be meet at the point I or at the point F, but though the a mirror is there of your the convex, then what will happen? This to be your the reflect from that position, and again this ray to be your the reflect. Similarly, this ray which was to be your the reflection for the first surface, now for your the second one, again this will act as your the incident, and again it to be your the reflect, and these both are to be your the reflect, and you have to make the modification, means some passage we have to provide. Though I have the facility of the erasing one, therefore I just make the erase. But while you are taking the note, if you will put on your the pen, then it will not be the erase immediately. Therefore I said that never draw this one, because some modification to be there. So here we have taken a passage. On this passage we have taken a lens, and for the lens, if these rays are meeting here, means they must come from your the another side. These are your the rays, and if we will plot the eye here, this is your the eyeball, you will have it's the vision. So this vision means the object was at the infinite distance. You see, for this case, this is the incident reflected, this is the reflected. But for this case, there is no magnification of your the object size, but the object as it is far away, it just placed before to you. So here there is no magnification. Therefore, this is it's the formation of your the image which was at your the infinite distance. Are you clear to my students? The object was at the infinite distance, and it being your the formed in front of your the eye, means at this position you are just visualizing to that one, and this was given by your the Cassegrain. Therefore, the name is your the Cassegrain type. And by making your the pose, you can take it's the figures formation. So now we will go to find your the second one, which is your the Newtonian telescope. Newtonian telescope. So according to the name of the Newton, the person where he has not given his hand. So in the every sphere of the physics he has given his the ideas. So in your the optics also, the Newtonian has given your the artificial instrument which is your the telescope. So in case of the Newtonian telescope, we also have to take in here the a mirror, because it is your the reflecting one. Similarly, the rays are coming from your the infinite distance. This is your the axis. And when the ray will come parallel to your the from infinite distance, the property is when the rays will come to your the from the infinite distance, they will come in your the parallel way. So these are the parallel way, and they to be meet at a point, and this to be your the focus where the image to be formed, but actually the image is not forming here. We have to take in another this type of mirror. Can you guess what is the name of this mirror? This is your the plane mirror. A plane mirror to be placed at an angle of your the 45 degree with your the axis. So when this mirror, plane mirror being the placed, and this is the incident one, this was the reflected. I have not make it here the totally black, and I have make it the dotted, because it is not, it's the real one. So this one which was the reflection for your the first surface, that image we are not observing, we are taking the another one. Therefore now you make this one as a bold one. So this is your the incident ray which to be the fall on your the eye. then it will give you the reflection. So if the object is somewhere else, this is your the image to be formed, but here the image is not actually will form. So you will now take its the perpendicular distance. Though this is your the mirror, if an object is placed at what distance, its image to be formed at the same distance behind that one. My students, you know very well, if you placed before your the dressing table, if your the size and your the distance from your the mirror, and you will observe for your the image one, both to be the same. If you will approach to your the mirror, then the image will approach towards you. So though this is a plane mirror, here the image to be formed, but actually is not forming here. Due to this plane mirror, if this will be the image, means it must have its the object at the same distance, and if this is its the image distance, the object distance must be the of same size, of the same distance. Suppose this is the image. So here the image will be the form, and this image will be formed, means this ray is falling, means this ray will come to meet at that point. Similarly, this ray, the second ray will fall on this mirror, and again it will be passed through that point, and it will pass, and that will be passed. Suppose you will have a lens here. This is the lens, and this is your the ray, and if you will place the eye here, the image to be the formed at this point. Therefore, this is also called your the reflecting one, because the reflection is taking place. So this is your the Newtonian telescope, and that we discussed, that is your the Cassegrain of the telescope, and the both the telescope with the figure and its the explanation was only in your the course. So this completes about your the ray optics regarding of your the optical instruments. As we came to know about the reflecting type of the telescope, now we are going to discuss about your the wave optics. So it is also the one branch of your the optics. Before that one, we are under the discussions of your the ray optics. So ray optics is deals with your the ray, and what is your the wave optics. The wave optics means it is also the combination of the two words. If we will go the meaning of the words individually, you must arrange your the some thinking about that of the space matter. Like of the wave, what is the meaning of the wave, and second one is your the optics. Wave is nothing but that is the disturbance which is created in your the any medium. In any medium, the disturbance which to be created. Suppose you are now observing your the television, and when your the program is coming, you are in the anxious position to see that what our the stars will say about our the topics. And before that, your television was in your the calm position, means your the study room or the where it being your the placed. If it is not your the functioning, your atmosphere or your surrounding is in your the in calm and the cool situation. But when the television being your the sounded, then there is some disturbance is created. That disturbance is known as your the wave. Suppose someone is shouting inside the home, then we will say that why you are making the disturbance. So the every disturbance which is created in the medium, that is known as your the wave. So for your the wave, which we are going to discuss about the light, the different concepts were related to that one. The first concept, it is come for your the particle in nature, which is called your the corpuscles nature, and in that corpuscular nature, they came to know that it consists of the very teeny particles, which are known as the corpuscles, and that corpuscles, if you go for its the dictionary meaning, that is your the very small particle or the very small part of your the any medium, that is called your the corpuscles. Like for your the biology students, you know that your the blood circulation chapters you came to know, inside the blood there are the RBC, WBC, they are nothing but your the corpuscles are there. So that concept and your the ray optics concept, nowadays it being your the discarded. A new type of your the thinking is related with the light, which is known as your the electromagnetic wave. So, regarding that one, we are going to discuss today for your the wave optics. So, wave means it is the disturbance, optics means the branch of the physics deals with your the light. So, if a light is taking place due to your the disturbance of its the path, then that is known as your the wave optics. Wave optics. This wave is your the disturbance and regarding the optics, you know the branch of light, a branch of light, that is your the optics. So, this wave optics is of the particle or your the ray. This concept is nowadays not taken into account. In nowadays, it being your the taken in your the electromagnetic wave. That is your the electromagnetic wave. So, this electromagnetic wave means again it is the combination of the two words. One is your the electro, second one is your the magnetic. Electro means your the electric field, magnetic means your the magnetic field influence. So, if a wave is having your the electric and the magnetic field influence, then that is known as the electromagnetic. So, wave means it is the disturbance. In case of the electric and the magnetic field influence, if some disturbance is going on, then that is known as the electromagnetic wave. And that electromagnetic wave is going in such a way that it has its the different characters. Number one is the electric field vector, electric field and the magnetic field are mutually perpendicular to the propagation of the wave. Means the electric field and the magnetic field, they are mutually perpendicular to each other. If you will look for your the screen, you will find that how the electric field it is being given in your the one color and the magnetic field it is given in your the another color. They are perpendicular to the plane of the paper. Means suppose this we have taken a 3D, this is the x, this is the y, this is your the z. Suppose the y is the electric field, z is your the magnetic field, then they are perpendicular to your the plane of the paper, means that is your the x axis. This is it's the first one. The second one is the speed of the wave, in the electric and magnetic field depends upon the material of the medium. The material of the medium means C is equals to 1 by root over of mu 0 epsilon 0. As I discussed, this epsilon 0 is your the permeability, this mu 0 is your the permittivity is corresponding for the magnetic field and the epsilon is corresponding for your the electric field. So, this is its the speed of the one, means it is independent of the magnitude of the electric and the magnetic vectors, field vectors. And this type of the natures is satisfied in your the electromagnetic wave, and for mostly of your the optics of your the wave, we are deals with the electric field vector. The electric field vector. Hence, the light is also known as electric vector. That is also known as the electric vector. So, regarding that of your the wave optics, different concepts being your the given, but according to our the syllabus, we have to discuss about a principle or the theory that is known as the Huygens theory, which is given by your the name of the, it is the name of the person of your the Dutch. So D-U-T we are saying the Dutch, but H-U-Y-G-E-N we can say here the Huygens. So someone will pronounce as the Huygens, someone will pronounce as the Huygens, someone pronounce as the Huygens. So whatever may be the pronunciation, but the spelling is the H-U-Y-G-N. So Huygens theory, number one is the light motion is a wave motion. And earlier we have, it is your the mechanical wave. Earlier concept was mechanical wave. Mechanical means having some medium. Having some medium. The earlier concept was it is your the mechanical wave. But now it is your the only your the wave. Means that is your the electromagnetic wave. So for the electromagnetic wave means, suppose the light is coming from the sun, what is the medium we will say? And for that one we thought that there is a hypothetical medium which is called your the ether medium. Inside the ether, the smallest particles which are present, they are known as your the corpuscles, and they are your the highly elastic, they are your the rigid, they are your the massless. These are its the characters. Suppose the light particles has some mass, and as we are coming out from the home, suppose the sun ray will fall on us. It has the number of particles. If the particles will have its the mass, then how will survive? Therefore, it is also your the massless, rigid, and your the elastic. So these are the concepts which are earlier taken, that is your the mechanical one. And the second one is every point of the light motion, every point of light motion will behave as source of disturbance. Source of disturbance known as secondary sources. Known as secondary sources. Suppose we have a point source, and from point source the light to be or the move in your the any direction. Means suppose the light is moving in this direction, 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 in this direction. So if this is the light motions, according to this, every point of the light motion, this is also light motion, means these each and every point, they again behave as the source of disturbance. Means from here also there is a disturbance, and these points are known as the secondary sources. From the secondary sources, the rays which to be or the comes out, they are known as the wavelet. They are known as the wavelet, and the collection of the wavelets is known as the wave front. That is known as the wave front. So we came to know about the Huygens theory of your the 2 points, and later we will discuss the another points. So one is the light motion is the wave motion, second one is the every point of the light motion will behave as the source of disturbance, and which is known as the secondary sources, and from the secondary sources which to be or the emit, they are known as the wavelet, and your the collection of them is known as your the wave front. Now we will go to discuss about your the term wave front. Wave front, wave means the disturbance. Next one is the front. The word, as I said that if you know the meaning of the words which are associated with that term, wave is the disturbance, front means which is coming ahead, means a wave which is going ahead, that will form your the wave front. But the question will ask in your will come to your mind, sir, why it is not going to your the back side? So for that one, if you came to know that the amplitude of the wave is proportional to half of 1 plus cos theta. theta is the angle which it makes your the with its the original position. Suppose the wave will come in your the backward. Backward means it will your the angle of your the 180 degree. So backward means just it to be your the complete it's the reverse position. Reverse position will make the angle 180. So cos of 180 that is equals to the minus 1. So 1 of the minus 1 that is equals to the 0. Means the amplitude becomes your the 0. Therefore it is not going to your the back side, only it is going to your the front side. So regarding that, the term is your the wave front. Wave front. So the wave front means it is the locus. It is the locus, not your the peoples. It is the locus, LOCUS, locus. You know in your the mathematics, for your the parabola, hyperbola, for the circle, there is a term comes here the locus. Locus means your the collection of the point. Locus means it is the collection. So it is the locus of points on the disturbance having same phase. Having the same phase. Suppose this is the point source, some waves are here the emitting from that one, and you know that y is equals to here the a sin omega t plus of phi or here the kx. That is your the formula you know for its the displacement. And if we will say that at the time t, suppose from here it is at the time is equals to the 0. At the time t it will come here, covering a distance of here the x. So of the same time it will come here, covering a distance of x, here also covering a distance of x, here also covering the distance of x, here also, here also, here also. So at the time t, this y will be, suppose the point is the y1 is equals to here the a sin of omega t plus of here the kx, likewise it will continue. So this point, this point, this point, this point, this point, this point all have here the same displacement, but this omega t plus kx will remain same for them. Means this omega t plus kx is known as your the phase. So for all the particles which are at the time of here the t with covering the distance x, they are of the same phase. Means if you will just collect them, simply you collect them, so that collection means that location of the points of the disturbance having the same phase, the phase being here the remain same, if you will connect them, then that is known as your the wave front. Means this is your the point source from where these waves are going of your the front one, therefore it is the wave front. That is called your the first wave front. And according to your the principle of the Huygens, every point of this one will again behave as the source of the disturbance. So likewise the point this, if that will be the another point, from there also the disturbance will be taking place. So again another wave front will be the form. And for this wave front, these points which will make the disturbance, they are known as your the wavelets. As I said, wavelets and your the wave front. So for the point source, the wave front is of your the spherical one. They are not corresponding for your the circular, because they are just passing. They are passing in your the every side. Means for the each and the every side of your the 3D. Therefore they will form your the spherical one. So for the point source, wave front is your the spherical. Similarly, if it is your the line one, means line source, suppose this is your the line, it has its the points, from these points it will give its the disturbance, and such type of your the disturbance will be the happens. So the disturbance will go on in your the every direction. So that line source, the wave front is your the cylindrical one. This will come in your the short question, cylindrical. So for the line source, that is your the cylindrical. If the source is your the coming from your the infinite in your the parallel way, the wavefront are of your the plane type. So for this is for the first case, this is for the second case. For the third case, the source is parallel, wavefront is your the plane one. Either this is your the source which is going in this way, so this is source and this plane, and this cylindrical with this plane, and for this point the rays which are going out and the rays which are going out, they are your the rays, straight one, they are the rays. So the ray, very important, the ray is this one, means what you are guessing from this one, perpendicular to the wavefront. So for the wavefront, the rays are always your the perpendicular. If we go for your the screen, it is clearly looking that the rays are your the perpendicular to your the wavefront. So taking these concepts of the Huygens, he is able to give here the or to show the laws of the reflection, the laws of the refraction, the diffraction, etc. It to be your the showed out by using your the wave optics Huygens theory. So let us now go for find or to prove the laws of reflection. Laws of the reflection. So for the reflection, we have to take in a surface which will act as your the mirror. Suppose this is the surface which is silver at the one side. Let us take this is your the plane wavefront. This is your the plane wavefront. So for the plane wavefront, for which one it to be formed? Just I said some minutes ago. For the plane wavefront, the rays are to be your the parallel. Means if the rays are the likewise, rays are coming from your the infinite in the parallel, the wavefront which they will form as I shown, this is your the plane. So this is your the plane wavefront. This is the plane wavefront. This is your the surface. This is your the surface. This is your the plane wavefront. Let us name it as your the AB. So for this one, these rays, not only these two rays, just I have taken it to the two extreme position. In between the extreme position, so many points are there, and you will take here the number of the rays also. If something to be satisfied for these two rays and other rays are parallel to it, they also satisfy your the same property. If this property will satisfy for the laws of the reflection. So what is the important property of the laws of reflection? You know from your the class 9th and in the class 10th, also in the class 11th and in the class 12, you know that I is equals to the R. This is the important property. So here the angle of incidence and the angle of the reflection, if they to be remain same, means we will say that it will satisfy the laws of reflection. So this is the one ray, this is the second ray. So if this is the ray, suppose this is the normal, take this point as your the B. So when this ray is coming here, actually it to be travel ahead. So after traveling ahead, it will meet your the plane surface, say it at some point C. So as it is coming from here, at the same time another ray was here. So what you will say? At the time if it is t is equals to 0, here also the time t is equals to 0, these rays are going ahead. So what will happen for this ray which was at the point B, it also move on your the same medium with the same speed. But the question will come to your mind that, sir, while the reflection happens, is the speed will remain same? So, never we thought that the speed will remain to be the change. The speed is only changed when it is going from one medium to the another medium. Though this is the reflection, if this ray to be the reflect, its speed is also the remain same. So, if it is the starting points, here t is equals to 0, here t is equals to 0, from here to here it will take the time is equals to the t, and if its the speed is the v is the speed of the wave, then within the time t from here to here, it will cover a distance of the vt. So, by taking the distance vt as the radius, taking the point P, let us draw a arc. So, if we draw a arc here, suppose the arc is drawn here. The question will come, sir, why the arc is taken at this position only? Why the arc is not taken here? Why the arc is not taken here? Why the arc is not taken here? From this side it will never to be happen, because it will satisfy for the refraction, but this is for the reflection. And why it is the arc is taken only that side? You see, just for your common sense, this is the incidence, means the reflection must be go in this direction. Therefore, we have taken the arc there. Suppose if we take the arc there, and for this point, so from this to this is the arc, and that also you are the cut the point here also. So, if you will just join them, means this one of what distance we have taken? By taking this one as its the radius, means this one is also your the Vt. Let us name it as your the C, and this is your the D. So, if the ray will come to this point, again it to be your the reflected. So, this is its the reflected one. This is your the incident, means this is your the reflecting, means it will go your the likewise. So, now you see these two are your the incident ray, and these two are looks like your the reflected ray. So, we have to show that for this incident one, this is its the reflected ray. Now, you come and give your minute attention. You see, this is the normal, this is the incident ray, this angle will be the angle of incidence, and though this is the normal, this is your the plane one. So, this total angle is your the 90, and this is your the ray, and this is your the reflected one, means they also making the angle of your the 90. So, this one and to be this one will be the perpendicular, as I written, the ray is perpendicular to your the wavefront. So, this is your the incident wavefront, this is means this angle will be the 90 minus I. So, if this angle is the 90 minus I, this one is perpendicular to this one, means this total angle will be the 90 degree. From this to this here the 90 minus I, then what will happen for this one? And this angle will be the I. This angle will be the I. Similarly, if this is your the reflected one, and we will draw a normal, this will be the angle of the reflection. And if this will be the angle of the reflection, this is your the reflected wavefront, this is your the reflected one, means this total angle again will be the 90, means this angle will be the 90 minus r. So, this angle is your the 90 minus r. Again this normal is to your the this plane, means this total angle is equals to your the 90, from this to this is your the 90 minus r, then what will happen for this angle? That is equals to your the r. That is equals to your the r. So, if you now compare the two triangles, triangles ABD and triangle BCD, if you compare the triangles ABD and your the BCD, compare ABD and your the BCD, ABD and your the BCD, you see this is the 90, this is your the 90, this is your the common side, and this one, and your the this side is your the Vt, this side is the Vt. You see, this side is your the normal, so this is your the normal. So, both triangles, one angle is your the 90 degree. Second one is, this one is your the Vt, and this one is also the Vt. So, two sides are to be your the same, Vt is same, means this is your the side, this is your the angle, and this one is its the common side. So your BD is common side, that is the common side. So though the sides, two sides and the angle means side and here the angle, the triangles are the similar. So if the triangles are similar means this angle and this angle to be here the same, because the same sides opposite angles to be here the same, means here the I is equals to here the R. So we have taken this is equals to I, but this I is mixed with which one? With this one. So this one is what we have taken earlier, that is the incident wavefront, and this is your the R. This R is making with which one? Is making with this one, and this one is what? It will be automatically, though this is the incident angle I and this R is your the angle of reflection, it makes with this one, means this must be your the reflected wavefront. So this is the incident wavefront, this is the reflected wavefront, and the normal, both are lying on your the same plane, that will satisfy the first law for the reflection, and the I is equals to R, that will satisfy the second law for the reflection. So by taking the Huygens principle, we prove the laws of the reflection. Now we will go to discuss the laws of the refraction, taking the Huygens principle. So what are the laws of the refractions? As I said that for the laws of the reflection, if one will able to show I is equals to R, then we will say that the 95% of the task is over, but not here the 100%. Similarly, for laws of refraction, laws of refraction. So for the refraction there are also the two laws, the incident ray, the refracted ray, and the normal at the point of incidence will lie in your the one plane. And the second one is the, which is the most important, that generally we are saying this one, but never my students you say in commonly sin I by sin R is a constant. As I explained before you for your the refraction, I said repeatedly, never you say sin I by sin R is your the constant. For the particular pairs of the medium and for a particular wavelength of the light only, sin I by sin R is your the constant. These two things you have to mention. As for your the Ohm's law, generally the students are saying V is proportional to I. That is not your the 100%. You always to say that at constant temperature. Similarly, there is another law which is called your the Hooke's law. The students will say that the stress is proportional to strain. That is not your the 100% correct. You have to say that within the elastic limit, the stress is proportional to your the strain. So for your the refraction, the important one is for a particular pair of medium, means if the medium pair being your the changed, then the sin I by sin R value to be your the changed. So I have taken the two mediums. So this is your the one medium, okay, this is your the second medium. On looking these two medium, what you are guessing? This is your the more particles are present, means this is your the denser medium, and the less particles are present means this is your the rarer medium. Suppose for your the denser medium you will take a refractive index, say this is your the mu2, this is your the mu1. So for your the refraction, what to be happen? When the ray will come from your the one medium to your the another medium, there is change in its the path. Suppose we will take this is your the wavefront, likewise your the laws of the reflection, and this is your the incident one, this is your the incident one. This incident ray will come up to this point, and at the same time this ray to be or the refracted, there it was the reflected, here it to be or the refracted. So there we have taken what distance it covered for your the first one, For the second one, that distance will remain same for the laws of reflection, because they are going in the same medium. But for the refraction, this ray, at the time of these rays travel, it is not in that medium, but it is in this medium. So when it is in this medium means it will go in its this is to be a straight way, it will never go in the straight way. When it will go from your the denser medium to your the rarer medium, what will happen? It will bend away from your the normal. So if this is the normal, it will bend away from the normal. And let us now join to this one. And this is its the normal, and this is again it should be the refracted one. So if this is your the I, sorry, this is your the incident one, this is your the reflected normal, this angle will be your the I, then this one is perpendicular to this one, means this angle is equal to the 90 minus I. If this one is at the 90 minus I, this is the normal to this one, means this total angle is your the 90. So if this is 90 minus I, then what will happen? This angle will be your the I. So this angle will automatically comes to your the I. Are you clear to my students? This is your the normal, this is the incident ray, so this is the angle of incidence. So though this is the ray and this is the wavefront, it is perpendicular, means this total angle is your the 90. So from this to this is your the 90 minus I. If this is 90 minus I, this ray is perpendicular to this one, means this total one is your the 90. If this one is 90 minus I, this was your the 90 minus I, this will be your the I. So if this will be your the I, from this to this, what distance it will cover? This is your the V1t. And what distance it will cover? Say this is your the V2t. And if this is your the normal, this is your the reflected one, means this ray, this angle is equal to your the R. If this angle is equal to R, means this total angle will be your the 90 minus R. And if this is 90 minus R, means from this to this, that is equal to your the 90, because this is your the ray and this is the refracted one, this is your the normal. So this total angle is the 90. Therefore this angle will automatically becomes your the R. So if this is the R, this is your the I, let us now you take your the sin I by your the sin R. So sin I will be how much? P by H. Sin R will be the how much? P by H. So this one will be your the, for the first one I, so this is the V1t by your the V2t. So V1t by your the side of your the this one, V2t by the side of this one. So that's the common side will be the cancel. So this t is cancel. So this is your the V1 by your the V2. So sin I by sin R, V1 by V2, it is nothing but your the mu2 by your the mu1. And this is your the Snell's law. This is your the Snell's law. So if the Snell's law is satisfied, the incident wavefront, the refracted wavefront and the normal, they remaining on the same plane, and that is your the another law for the refraction. Therefore the laws of refraction is also satisfied by taking your the Huygens principle. So either for the laws of reflection or for the laws of the refraction, the law to be satisfied by using the Huygens principle. Thank you very much.